Hello and welcome to NASA's Jet Propulsion Laboratory in Pasadena, California. I'm Preston Dykes. Well, we are at the end of an era in planetary exploration. In less than 2 days, NASA's Cassini spacecraft will make a fateful final plunge into the atmosphere of Saturn, collecting data until the very last moment as it ends its 13-year tour of the Saturn system. The purpose of our briefing today is to provide background on how we got here with Cassini, along with preparations for the final plunge and some of the science that the Cassini team helps to accomplish as Cassini heads into Saturn. Our participants for the briefing today are, from NASA headquarters in Washington, the director of NASA's Planetary Science Division, Jim Green. Up next, we have the program manager for Cassini here at JPL, Earl Mays. To his left, the Cassini project scientist, Linda Spilker. And finally, team lead for Cassini's Ion and Neutral Mass Spectrometer Instrument, or INMS, from Southwest Research Institute in San Antonio, Hunter Waite. All right, a reminder to reporters dialed in on the phones, please dial *1 to get in the queue to ask a question. And members of the public, as well as the media, can ask questions online via Twitter using the hashtag AskNASA. And with that, let's turn it over to Jim to get started.
Thank you very much, Preston. You know, we're here at a very historic time, but it really started with the Voyagers. Voyager 1 and 2, as we see here in the auditorium, a full-scale Voyager passing through the Saturn system, begging us to go back. And of course, in 2004, Cassini made it to the Saturn system. And as you can see, Cassini, this is a smaller scale model, but if you can imagine the antenna size on Voyager being the same as Cassini, this is a very capable, large spacecraft that has been making fabulous measurements within the Saturn system. My first slide, please. Of course, Saturn, one of the beautiful gas giants in our solar system with the beautiful rings. But studying the planet itself has been incredibly important. The cloud dynamics and the storms that occurred. And in fact, while Cassini was there, a storm that lasted more than 9 months raged in its northern hemisphere. Next slide, please. Of course, as we were able to get to higher latitudes, we were able to look down at the polar region and see other spectacular things. The hint of this hexagon pattern on the North Pole was really observed first by the Voyagers, but we're now back to see that up close and personal. The size of this whole hexagon, which is actually a jet stream on the outer rim of it, is about twice the size of our Earth. In addition to that, we had opportunities to begin to look at the moons. And here, other surprises were well in store for us. As seen in this image, this is Enceladus. This is a small moon just outside the rings of Saturn, and what we thought was an icy ball when we observed the southern hemisphere in geysers of water spewing out into the Saturn system, it amazed us and began changing the way we view the habitability or potential habitability of moons in the outer part of our solar system. My next image, of course, is the beautiful Titan. This moon is bigger than the planet Mercury. It has an atmosphere twice our atmospheric pressure. If it was orbiting the sun and not Saturn, we would call it a planet. It's truly a magnificent body. The Voyagers could only see the haziness of this beautiful object, but with Cassini, our ability to penetrate through that haze with our radars and seeing what the surface structures and features are, and the ESA Huygens probe going all the way down to the surface revolutionized our understanding of this spectacular moon. This is the only other body in the solar system that has liquid on its surface. Its seas are about the size of our own Black Sea. Now, they're not full of water, but they're full of liquid methane. This is a spectacular world in its own right. Next slide, please. Of course, Saturn has more than 60 moons. Can't see them all, but we saw approximately 24 of them, in addition to Enceladus and Titan. Beautiful moons with all sorts of structures. Those that even, in fact, modify the structure of the rings, creating divisions, or elements that accrete material, and we begin to see all those processes up close and personal. But one of the real stars of the show is Titan. Our ability to fly by Titan, which is about 20 Saturn radii away from Saturn, allows us to use the very basic principle of gravity assist to change the plane of Cassini's orbit, provide new views, and therefore observe in beautiful different ways. The next animation shows you these flybys. Now, what we normally do on flybys is just get a little idea of what that body is, but these flybys have revolutionized our opportunity to use this concept for other missions. We now know from these flybys how to construct a global view of this beautiful world, and we're using it on the Clipper mission that's going to Jupiter and viewing the moon Europa. Cassini has enabled us to make those future missions possible. My next slide, please. Americans had a wonderful view of an eclipse where the moon passed in front of the sun last month. Millions of people appreciate now what eclipses are all about. From our view on Cassini, this is the eclipse, with Saturn moving in front of the sun. This allows, in the low light of blocking the sun, opportunities to see in greater detail the ring structure and other elements. In fact, we were even able to see distant planets and the Earth in a beautiful set of mosaic images that have been stitched together as shown here. That outer ring that you see is called the E-ring. We're able to illuminate it in ways that tells us that Enceladus' geysers of water being spewed out is creating this ring. Now, because of the importance of Enceladus that Cassini has shown us, and of Titan, another potential world that could be habitable for life, perhaps not like we know it, but perhaps completely different than ours. We had to make decisions on how to dispose of the spacecraft. And that led us inevitably to the plan of taking Cassini and plunging it into Saturn. Because of planetary protection and our desire to go back to Enceladus and go back to Titan, go back to the Saturn system, we must protect those bodies for future exploration. Next slide, please. Well, in the visible camera, we've seen more than 450,000 images. Every one of them in their own way are absolutely spectacular. But we made the decision to go through and pick the top 100 images, videos, and animation and create an ebook, something that allows us to go back and view what we accomplished and the beautiful observations that this mission has done. You can download this ebook in several formats at nasa.gov/ebooks. So with that, let's learn how we plan to plunge Cassini into Saturn and what we will learn from that experience. So let me turn it over to Earl Mays, the project manager for Cassini. Earl?
Excuse me. Thank you, Jim. It's been such a unique and incredible privilege and pleasure to operate this spacecraft that before I go into its demise, I'd like to talk just a little bit about some of its many accomplishments. As Jim pointed out, almost half a million images taken, 4.9 billion miles logged on this spacecraft, 635 gigabytes of data played back. Now, that by modern standards is not a whole lot bigger than a flash drive, but you got to think about 80s technology from a billion miles away, and that all of a sudden becomes pretty amazing. We had 162 targeted flybys, and as Jim pointed out, we've been using Titan to great advantage, and there have been 127 of those. Could I have the first graphic, please, just to show you this incredible spacecraft? Now, it's twice again the size of the model in this auditorium if you're here, but it's absolutely splendid, just a built for Saturn. And of course, that's the iconic North Pole of Saturn below it. Now that is an animation. We did not take a selfie stick with us, although those we could have put one on the RPWS antenna in hindsight. That again was something that the 90s didn't know about, so we'll have to live on it. But again, it's just been almost flawless operations in both the instruments and the spacecraft engineering systems, and then the ground support itself, again, has just, I think, made this mission. Not only do we have an environment that just is overwhelming with abundance of scientific mysteries and puzzles, we've had a spacecraft and a team that could exploit it. So again, I will probably come back to that point, but it's just been an amazing, amazing mission. So what are we going to do? Let's get to the last few hours. Could I have the next animation? This is the so-called ball of yarn. What we do, as Jim pointed out, we have a main engine, and it's a great main engine, but we've got Titan, and Titan is a phenomenal main engine. Every time we fly by Titan, we get a little bit better view of Titan, and we get a little bit better view of the Saturn system. Every one of those course changes, every orbit change there is Titan's doing it for us, and it's done it for us for 294 different orbits. 127 times we've made major orbital changes, and Titan's been at the center of every one of them. So that's the ball of yarn, and if I could go to the next one, let me just show you what Titan did for us. This was April. All the time we've been outside the rings and paying very, very careful with the rings and with the dust because we really didn't understand the environment well. But for the grand finale, in order to exploit every last ounce of our propellant and the science that Saturn offered inside, we've been in what we've been calling the proximal orbits, or the grand finale. Titan gave us one last little nudge back in April and pushed us, the Cassini spacecraft, between the rings and the planet itself. And we've been skirting back and forth and back from that for 22 times since April. Our last one, unfortunately, was Saturday morning. We had, or Saturday evening, actually. We got the call back on Saturday morning. We don't normally communicate with the spacecraft during these passages because the science is so precious. We were busy gathering that. So the call home was Saturday morning. We were here, got the call home. The spacecraft's fine. It did it again the way it always has. Monday, we got the kiss goodbye from Titan. 119,000 kilometer altitude flyby from Titan. Took about 39 meters per second of velocity away from the spacecraft. Slowed it down just enough that what's going to happen on Friday is absolutely inevitable. So if I could go to that next animation, just to show this. There is a graphic here. See that Titan flyby? No, that's behind me, I should be pointing. That little Titan flyby was enough to put us into Saturn. It was just distant enough, just close enough, and just the right orientation to seal Cassini's fate. So what's going to happen next? If I could get the next graphic, please. We made contact with Cassini for the last time, I mean, for the penultimate time. We seized contact about 6:50 this morning. After the Titan flyby, we got a call home last night. We were all in the mission support area waiting for telemetry. As it has done over and over again, Cassini came in on time and in perfect shape. It got the flyby that it needed, it got the velocity change it needed, and it's now on its way into Saturn. But before it goes, at about 6:50 this morning, it turned off of Earth back to the job it's been at for the last 13 years, observing the Saturn system. It's going to be taking the last set of pictures of some of the prime targets that it's visited over the many years that it's been at Saturn. And we'll be able to share those with you sometime on Friday. They'll be coming back tomorrow. About 2:45 tomorrow afternoon, Cassini's going to turn back and play back those final sets of images. We figure that to take about 11 hours. So at about 1 o'clock in the morning of Friday, September 15th, we will, the solid state recorders on board Cassini will be empty. And we will then reconfigure Cassini for its very final transmissions. What we're going to do is, Cassini is normally a mission that stores things on data, it's like it's doing right now. We're not in contact. We could look all we wanted, and Cassini's off busy doing its own thing. Stores it on the recorders and then plays it back later. It's doing that right now. But next Friday morning, we're going to turn Cassini into what we call essentially a bent pipe transmission system. Everything that comes from the instruments is going to go right into the recorder and right back out. So there'll be a few seconds delay, but it's essentially now a real-time instrument. And that's to enable the sampling instruments, particularly the ion and neutral mass spectrometer, to get data as deep into the atmosphere as Cassini will permit it. We've taken our data rate down to as low as we can handle so that no matter what antenna we've got on the ground, we'll be able to receive it. So if it's a rainy day in Canberra, in Australia, where we'll be tracked, then we'll be able to have a better chance of getting the data. We've also got antennas both at the DSN tracking plant, stations on the east side of Australia, but also we've got the New Norcia ESA station standing at the ready on the west side. So if we've got a rainy day over the entire continent, well, we're out of luck. But as best we can do, we've got ourselves covered. We will turn at that point also to make sure that the high gain antenna, the large dish you see there, is pointed directly at the Earth. And then we've rotated the spacecraft so that the ion neutral mass spectrometer's aperture is pointing directly into the oncoming atmosphere. So essentially it's getting just a full blast of the atmosphere as it comes in. So how are we going to, the last few minutes? Cassini was not built for atmosphere. As you might imagine, we're a deep vacuum kind of probe. That's not to say it hasn't seen atmosphere. We've flown into the atmosphere of Titan. We've used the thrusters to battle that, the torques and the drag forces that we've had to deal with. And they've been very effective at it. So we know how to fly into a little bit of atmosphere. And we've been doing that for the last 5 orbits. We've actually been dipping our toes down into Saturn's atmosphere for the last 5 orbits. And the thrusters have had to fight back. At what we call a duty cycle, at 100%, they're working as hard as they possibly can. They've been up to into the 40s. So we really have been working the atmospheric effects to some extent. We have a good sense of these. But these are really tiny thrusters. They're built to move a school bus by just kind of tapping it. So they're just not going to be able to do that. I think I'm getting a 1/8 pound. So this is just, you keep touching something, pressing out a little bit, it's about 1/8 of a pound. You can imagine what those thrusters have to do in order to deal with the atmosphere of Cassini. So before I go on to the next animation, let me just point out one final moment. Here, and at 4:55 a.m. Pacific Daylight Time, loss of signal. And what's going to happen is the thrusters will eventually be overpowered by the atmosphere. We won't watch Cassini burn up. What we'll watch it do is slowly turn away from us. And we'll watch an indicator on the radio science displays that will go down flat and essentially loss of signal. The mission will be over within a minute later. It's going so fast and the atmosphere is thickening so quickly that Cassini will be vaporized in a few, I think maybe 2 minutes, but I think more like 1. So it's just inevitable. It's going in very fast, very steep. Let's go to the next image just for fun to see. There's the timeline of the last 90 seconds of Cassini. Every 10 seconds tick mark there. And that tick mark, as you can see, the final one on my right is, on my left up there I believe, is where we will lose signal. So you can see very, very tenuous atmosphere, where essentially the analog of that might be on Earth. That's about where the International Space Station is relative to internet density. It's very, very thin air. But Cassini's going so fast, and the thrusters are so modest for this sort of requirement, it's just not going to last much longer. But you can see that about 70 seconds, 60 seconds in, the thrusters are going to start to fight. For the last minute or so, they will be fighting the atmosphere increasingly as it tries to turn Cassini into a more aerodynamically compatible shape. And eventually they will overcome. So if I could see the last graphic, please. This is an animation, and so there's Cassini coming in. This is about that point. You can see we're starting, this is again a bit of a artistic license here. But the thrusters, as you can see down off those extensions on the bottom, are fighting extremely hard to keep the antenna pointed directly at the Earth. And you can see it's going to start to feel the vibration of some of the atmospheric torques. But it will fight, and it will fight, and it will fight. The mass spectrometer is pointing into the atmosphere. The antenna is pointing at the Earth, and it's going to do that for as long as it possibly can. Those of you that have been following this story for a little while might have noticed that we've been a little bit ambivalent about when Cassini's actually going to lose signal. One of the wonders and mysteries of Saturn is that we are always surprised. And we thought we knew what the atmosphere was all about. We had models that told us we were perhaps not going to get enough atmosphere to even satisfy the INMS requirements during the last 5 orbits. We had plans to pop down into the atmosphere. And if it was too thick, we had plans to pop up and pop up again and pop down in order to get this thing fine-tuned. Well, it turned out to be absolutely perfect against all of our predictions. We had all these contingencies planned and we threw them away. But what that tells us also is not only we do not know the atmosphere, but the atmosphere affects when you're going to go in. Every time you go into the atmosphere and get slowed down, well, you go in a little bit earlier. So what started as 5:08 is now at 4:55:06 a.m. Pacific time, and that's our story, and we're sticking to it. So with that, I'd like to turn the mic over to Linda Spilker to tell you about some of the just amazing science that we're going to get in these last few hours.
Well, thank you very much, Earl. Being part of the Cassini mission for the entire mission has been an incredible privilege both for me and for many of the scientists on board Cassini. We've had an incredible 13-year journey around Saturn, returning data like a giant fire hose, just flooding us with data. In fact, if you imagine all that data as a million-piece puzzle, Cassini has been slowly putting together the pieces. We have some of the border, some of the regions, and we're trying to put together the picture of the Saturn system, but we don't have a picture on the cover to guide us, to tell us what that final set of data will finally look like. And what's really great about the grand finale is it's adding incredible new puzzle pieces to help us better understand the Saturn system. And as Earl said, lots of surprises. Many of the things we thought we knew about Saturn are more complicated than we originally had imagined. If we look at the first graphic, this is an example of looking at Saturn from the outside in. That's what we're doing with the grand finale orbits. If you look at that blue figure on your right, that's the auroral oval at Saturn. The particles come in, hit the atmosphere, cause this wonderful aurora. Just underneath it, you have the hexagon with the hurricane inside it. If you look on the bottom right, you can see an image now in the infrared where you can see the heat energy coming out from inside of the planet. And finally, that beautiful image with the hexagons. So we're looking at different levels from Saturn, almost like we've taken a magnifying glass to the planet and the rings. We've also been looking at the interior and, in a sense, pulling back the curtain with our gravity and magnetic field data to see what Saturn is like on the inside as well. Well, as Earl mentioned, we're going to be taking our last images. We hope about 8 o'clock tomorrow night to have the images up on our raw image site if we go to the next graphic. In that last period of time, looking around Saturn, what we're doing is we're taking our final picture postcards of the Saturn system, looking at our favorite targets, and to put these images in our Cassini scrapbook. So we're going to take, if you look at the upper left, a mosaic of Saturn and the rings in color, basically our last look at the entire system. Upper right, that's Titan. We're going to take some goodbye pictures of Titan, last look to see if there's any weather or clouds going on. In the lower left, that's the outer edge of the A-ring, and that bright feature is created by a grouping of particles that we've nicknamed Peggy. We've been watching since 2012 to see if Peggy might break free of the rings and become a moon in her own right. So we're going to take a last look, see what Peggy's up to. In the center, we're going to watch Enceladus set behind the northern limb of Saturn, so very appropriate Enceladus setting. Get a look at the propellers, that's on the lower right, these objects that are trying to open up gaps in Saturn's rings, not quite big enough to do that, but you can only see those with a spacecraft like Cassini. And then on our final moments of data, we're going to look on the dark side of Saturn at that point where Cassini will be plunging into the atmosphere. looking in the near infrared, the ultraviolet, trying to get some pictures of Cassini's final home inside the planet Saturn itself. Now, if we go to the next graphic, this just came down last night. This is one of our looks at Titan from the Goodbye Kiss. The North Pole, you can see the lake region. We're looking at the North Pole of Titan. Looking through the haze has cleared remarkably as summer solstice has approached. And then if we go to the final graphic, these are the instruments that will be on and sending back data during those final moments with Cassini. And we have 8 of them, including the ion and neutral mass spectrometer, the magnetospheric imaging experiment, the radio science system will be sending back its last gravity measurements, the radio and plasma wave antennas, and then the ultraviolet and infrared spectrometers will also be taking data in that time period, the magnetometer, and the dust analyzer as well. Now, in these very final seconds, we'll be plunging deeper into the atmosphere of Saturn than we've ever gone before. In fact, you can think of Cassini as becoming the first Saturn probe. And to tell you more about sniffing the atmosphere of Saturn, I turn it over to Hunter Waite, and he's the principal investigator for the ion and neutral mass spectrometer. Hunter?
Thanks, Linda. The ion neutral mass spectrometer is actually the sensitive nose of the spacecraft. If we go to the next graphic and zoom in on INMS, you can also see it here. Gas enters into this front portion of the instrument, and inside the molecular composition is determined. And so we have to be pointed in the forward direction, in the direction motion of the spacecraft, as Earl's already indicated. We've done this on many occasions. We've explored the atmosphere of Titan in the same manner. We've explored the plumes of Enceladus with the ion neutral mass spectrometer as well, and found out about the composition there and made some inferences about the internal ocean. And now we get a chance to actually look at the atmosphere that's created in the rings itself and the atmosphere of Saturn. So we're sampling both in this last stage. If you go to the next graphic, there's some idea of the sampling that we're doing. So the 5 dots indicate the 5 previous orbits where we were at the lowest point or closest to the atmosphere so far. Earlier, we were closer to the rings. And we were close to the rings. There's kind of like 3 bands that we actually sample. So we've had a chance to look more at the ring atmosphere and to look and to progressively see more and more of the atmosphere of Saturn itself. And you can see that line on the graphic. It's called well-mixed atmosphere. That's where the atmosphere becomes kind of homogeneous in terms of composition. And we're not going to quite make it to there, but we'll make it close. And in that period of time, we'll be able to make our cleanest sample of the atmosphere of Saturn itself. So if we go to the final graphic, this is a very pretty picture of the rings and of the atmosphere. You can see kind of a haze, which is the atmosphere, just above the edge of the planet. And one of the most important scientific things that we're trying to figure out is a concept called ring rain. And this concept was introduced in the early 80s to actually explain some observations that were made by both Pioneer and Voyager as they flew by. And this particular ring rain was actually water vapor and ice grains from the rings falling into the atmosphere and making modifications to the atmosphere and ionosphere. Well, as Cassini has always delivered, ring rain is much more extensive than that. It's much more complicated. We're getting great new data. We're trying to find out exactly what is coming from the rings and what is due to the atmosphere. And that final plunge will allow us to do that. The other thing that we'll do during that period of time is as we move closer to the mixed atmosphere, we'll be able to look at some important constituents that we know are there, and we've been measuring them, but we'll get a better idea of the hydrogen to helium ratio. And this is important in terms of the formation and evolution of Saturn itself. So we have an extensive set of science objectives that we're going to execute on this final plunge, and we're looking forward to getting the data in near real time. Thanks. I'll pass it back to Earl.
Thanks, Hunter. After nearly 4 decades of planning, execution, implementation, and execution, we are now within 48 hours of the end of the Cassini mission. The work of 3 space agencies, 17 member nations, hundreds of suppliers, thousands of engineers, scientists, and support staff are about to come to a fiery end high above the clouds of Saturn. The current Cassini team, or family, as it has become, comprised of hundreds of engineers, scientists, and support staff, has worked for many years to bring us to this point, and has done a phenomenal job. As I emphasized at the beginning, this is about a spacecraft and a team that has just been absolutely the best one that could ever ask for in both cases. And it's coming to an end, unfortunately. We'll be saddened, there's no doubt about it, at the loss of such an incredible machine. But I think all of us, we're going to have a great sense of pride in a little bit corny perhaps, but mission accomplished. We set out to do something at Saturn, we did it extremely well, and we delivered more and more. And we've left the world informed, but still wondering. And that's, I couldn't ask for more. We got to go back, we know it. We've been gathering all week, and we'll be staffing up the Mission Control Center tomorrow, standing vigil through the night as we prepare to say goodbye, both from here and a large crowd of our team members at Caltech, as our faithful traveler from Earth makes its final goodbye. So thank you, Cassini, and farewell.
All right, well, thank you very much to our speakers. It's just phenomenal. We're going to go ahead and open it up for questions, first of all, to reporters here in the auditorium. Please wait for the mic and give us your name and affiliation. Any questions here? We'll start down front.
Thanks. Hi, Irene Klotz with Aviation Week. The last image that's going to be taken from Titan, is it, from Cassini, is it the image of where it's going to impact? And what is the speed that Cassini will be traveling relative to Saturn in the final descent?
I think the answer is yes to the first question. The final image is...
The final image is the place where Cassini will plunge. It'll be dark, but we'll take an image there, yes.
And in miles per hour, we're going about 76,000 miles per hour.
We'll actually have an image with our visual and infrared mapping spectrometer, and that image can sense the heat of Saturn as well. And so we may see some details of the atmosphere in the near infrared.
Thanks. And the 4:55:06, that's Pacific Daylight Time.
Pacific
and
Daylight
what is
Time.
the actual time on with the...
It's about an
with
hour
the
and
delay?
21 minutes.
Okay.
Or that takes the signal an hour and 23 minutes to get from Saturn to Earth. But as far as we're concerned, that what we see is, and what we live with is the signal from Cassini. So when that last signal comes down, that's when things have happened for us.
Okay, another question here in the audience, down front.
Frederick Castell, freelance journalist. 2 questions. When you look at the ephemerides of the different moons, do we see some kind of pioneer effect on the Saturn system? And the other question is on the long term. For next mission, future mission, what's the strategy about plutonium?
I'll start with the pioneer effect, but I'm going to let Jim handle the next one. No, we have not. Because we have so many different perturbations in the system, from the moons, from our own thrusting, from the thermal pressures of the RTGs, even more subtle. We're just too busy perturbing that trajectory to actually be able to see something as subtle as the pioneer effect. It's just too much going on in the Saturn system.
Several years ago, we were able to work with the administration and Congress to get the approval to restart the production of plutonium-238. We've already done a number of tests, and in 2019 we'll get back into the production on a regular basis. We also have approximately 30 kilograms plus of plutonium available to us for future missions. The next plutonium mission that we planned is a Mars mission. It's Mars 2020. But I think we're in really good stead for the next several decades. Our plan is to keep a stock of plutonium and not let that be a mission-limiting factor.
Okay, other questions here in the audience? Right here, we'll go inside and then outside.
Hi, thank you for doing this. Will we be able to tell anything from the live stream data on the way into the atmosphere right away? And if not, how long will it be before we know a vague idea of what it's telling us?
That's yours.
Well, the data, the operations team lead for the INMS tells me that she will display it 20 minutes after the time we take it. So we're going to get it streamed to us from the downlink to JPL, be transferred to Southwest Research Institute, and then we'll have it on a computer down in Caltech.
Understanding it might take a little bit longer.
It could, but that's our plan.
Lee Hotz, Wall Street Journal. You mentioned that Cassini has, among its many accomplishments, enabled a series of missions to come. I wonder if you'd expand on that for a moment.
Well, as I mentioned earlier, the concept of the gravity assist that we were able to get with Titan allowed our instruments to get a global view of that beautiful moon. That's really spectacular because that means when we take it to the Jupiter environment where the radiation belt is really harsh all through the area where the Galilean moons are, we want to be able to get in and get out. And so then if we orbit Jupiter, we can do multiple flybys of the moons, and the one we're planning to do is Europa. And from those multiple flybys, actually create a global view of that moon as if we were in orbit. And so Cassini has really pioneered that whole concept, and that will be our next attempt in using that to great effect.
All right, actually, we're going to go to the phones now for a couple of questions, but we'll come back to the auditorium. I think we have Marcia Dunn from the AP. Marcia?
Yes, can you hear me?
Sure.
Yes, for either Jim or Earl or both, there seems to be the outpouring of love for Cassini seems to be growing in these last hours and days. I'm wondering if you had a chance to hear the Cassini opera from the Planetary Society. What did you think about that? And how do you feel hearing from the public who's so sorry to see Cassini go?
I have heard the opera tribute from the Planetary Society, and I loved it. It's very heartwarming to us. As a matter of fact, we've recently posted a letter from a 6-year-old boy who invited us to his Cassini party in Florida on the 15th. The feeling the love, if I may be so corny, is just very heartening because it's part of what we try to do, is to extend everybody out to Saturn. It's not science for, in the ivory tower. It's for humanity, and for everybody to get on ride, come with us, is just phenomenal. So I'm very heartened by that. I wish. Well, never mind. I don't even want to go there. One more orbit. So it is where it is. We've gone this train, and I couldn't be more heartened by the outpouring we've had.
Absolutely. The Cassini family, as Earl mentioned, is those people that have worked many years, decades, to get to this point. And we are absolutely delighted to have an extended family, to share the experiences that have really enabled enormous science to be done. And in fact, really the science is not done until we share it. This is really just the beginning of a number of discoveries that the data will reveal as we try to figure out what the physical phenomena are that are being described in those observations. Those will live on for many decades afterwards, and already they're beckoning us to go back. Between Voyager and Cassini was 30 years, and I believe that will be much shorter the next time around.
Okay, we're going to take a couple of questions from social media. We've got Jason Townsend from NASA headquarters. Jason, what's going on?
Indeed, there's a lot of interest online here. Our first question here comes from Salma on Twitter, who asks, will Cassini completely evaporate in the atmosphere of Saturn, or will it crash into the surface of the planet?
It will be completely vaporized, like many meteorites at Earth. It won't. If there is a surface at Saturn, it's at a hellishly hot and pressure and temperature, and anything from Cassini will have vaporized long before.
Wonderful. Lots of other questions here asking about images here. So Evelyn on Twitter asks, will Cassini be able to take a close-up image of Saturn as it plunges?
No, we don't have the data rate to support sending back images in real time. So the instruments that I showed you did not include the cameras for those final few moments for the plunge. So we'll be getting those images back. The final image will be of the place where Cassini will go, but it'll be from about 14 hours earlier.
All right, next question here comes from Twitter user Billiman, who asks, would it be possible to use a low-gain antenna at a very low bit rate to monitor a heartbeat from Cassini just a little longer?
I'll repeat that for the audience. The spacecraft engineer is in the second row, and the answer is a resounding no. If we'd done that, we would have given up some science data, and really for a few seconds more to get those last packets of spectrometer data was much more important.
Okay, we're going to go back to the phones. I think we've got Leo Enright from Irish Television. Leo, can you hear us?
Yeah, thanks very much. In fact, my question isn't entirely unrelated to the last one, because I'm wondering, there has been some speculation that a good telescope on Earth, and I presume a really good one, would be able to see this happen. Is that the case?
Well, we're going to try and look with telescopes from the Earth. We're just not sure. This flash will be occurring on the day side of Saturn, and we've done some calculations about brightness. We think it's not very likely, but we're sure going to look anyway.
Okay, one more question on the phones. I think we've got Dave Mosher from Business Insider. Dave, are you there?
Can you guys hear me?
Yeah, we sure can.
All right, great. Actually had a follow-up to the previous question and then one more new one. Do we know which observatories in the Southern Hemisphere or wherever on Earth are going to be trying to see this thing? That's my first question for whoever can best answer it. And then sort of related to that, but about the data that's coming back, I just checked the forecast for Australia, and it does look like there's a little cloud and rain in the forecast for the next few days. I'm curious if you guys are worried about that at all, or if you're confident that you're going to get this data back. Thanks.
Well, the observatories we're going to be using are mostly in Australia. Australia, of course, Canberra has a great view of Cassini. Also, we're going to be using some smaller telescopes. We're going to try and look from India, from China, possibly from Taiwan. We're really encouraging our amateurs, too, to get out there and look with their telescopes. We don't have any giant telescopes in that region where we can see Cassini. So we're just saying, hey, everybody go out, take a look, and we'll see what we see.
We have every confidence that we're going to get the data back. It's going to take a pretty hellacious rainstorm to take out the data. We've got our data rates down at a very low level. If we can maintain the 70-meter antenna, we have a lot of margin. If we do lose the 70-meter dish, then our margin is a little bit lower, but we're still, I believe, comfortable. Worst case, we still have the new Norcia complex over on the other side of the continent that is not really prepared to decommutate our telemetry immediately, but all the data will be on the ground and we can build the right system to take it back apart. So we'll get the data. It's just a question of how soon.
Okay, thanks guys. We're going to go back to social for a couple more questions. Jason?
All right. Twitter user Jason asks, when will a spacecraft visit Saturn again?
That's
Jim.
That's for me. I sort of begged for that question. The observations by Cassini have been so remarkable for Enceladus and Titan that indeed last year we announced the inclusion of those two objects in our focused science program called New Frontiers. Those proposals are in and currently under evaluation, and they do indeed include proposals to go back to Titan and Enceladus. So we'll look through this competition and see what happens.
Okay. You got another question there, Jason?
Sure. This one comes from Pietro, who asks, if you could go back and change something in Cassini, an instrument or skill, what would it be?
Hunter, you want to take that? Okay. If I could go back and change some instruments on Cassini, I think I'd select flying some more capable mass spectrometers. You know, if we had known about the geysers on Enceladus ahead of time, that would have perhaps guided us, something to go back and perhaps look for amino acids, fatty acids, possible evidence of life. So if I could change one thing, it'd be to carry some spectrometers that could do some work for looking for life.
I wouldn't have touched a damn thing. You know, we went in with everything we possibly could. We had the Swiss Army knife, and now we know so much more. Now we can fine-tune it. But this spacecraft, like I said, I couldn't have asked for anything. Anyway, I couldn't have asked for anything more.
All right. We're going to come back to the room. I think Emily, get a.
I'm Emily Lochtawala with the Planetary Society with a couple science questions. Hunter, I'm wondering if you could tell us a little bit more about that ring rain concept that you're trying to test and what you're learning about it. And Linda, I know that there's a science team meeting going on this week. I'm wondering if you can share any of the early exciting results from the Proximal mission.
Well, the ring rain concept, as I mentioned, was first introduced in the 1980s. And it was a concept of material from the rings, mainly water vapor and ice grains, descending into the atmosphere and causing changes in the atmosphere. And we have measured that, and we do see the water, but we see other constituents as well. So it's much more complex than we imagined before. And we'll be, we're traveling at 31 kilometers per second, and gases coming into our instrument very fast and with a lot of energy, and so there's potential to break it apart. And so we're working very carefully to understand that before we go out and tell the public what we're seeing.
Yes, Emily, we're having one of our Project Science Group meetings. In fact, it's the 73rd meeting we were having of this group since we first got started. And there have just been some tremendous presentations about the grand finale science, some of it only days old. And what I can tell you is that many of our models we're finding out are too simple or just out and out wrong. And so the scientists are carefully looking at and calibrating their data and comparing notes and discussing it. And there's nothing that makes a scientist happier than finding out, hey, my model's wrong. I have to sort of start over and work it through. So we have a lot of very, very happy scientists. We're meeting down at Caltech. And so hopefully in the coming months we'll have some answers. But in particular, the interior of the planet is very different than we expected. Its gravity field is not at all what we expected from our models. Also the magnetic field. We're finding that the rotation axis of Saturn and the magnetic field axis are almost perfectly aligned. And everything we think we know tells us that if you don't have at least a small tilt, you can't maintain those currents that sustain a magnetic field. So we have some more thinking and some more work to do.
Okay, questions here? I think there's one in the third row.
Hi, Robert Perlman with Collect Space. Not that there be any way of verifying this, but has there been any modeling or any even best guesses of how Cassini is going to come apart and what might be the last piece to survive?
Yes, there's been very thorough analysis, piece by piece deconstruction, if you will, of Cassini. And we believe that the final components to be destroyed will be the aeroshell components that are wrapped around. Cassini has these radioactive power supplies, and each little slug of plutonium is wrapped with iridium, and then they're put inside an aeroshell that would, in order to avoid any possible release during a launch accident or reentry. And that's just the iridium has a very high melting point, and the material around them is even higher. So those will be the last pieces. Other than that, taking those, the parts of the spacecraft that will be shielded away will last a little bit longer, but a lot of the spacecraft is aluminum. It's going to melt very quickly. A lot of it's carbon fiber and mylar and things like that, and they're going to go very quickly.
Okay, how about some more social media questions? Can you?
Sure, here's two good ones here. The first one comes from user Anchel, who asks, what is the last bit of data that we will receive from Cassini?
The very last bit of data will include the ion and neutral mass spectrometer data, but they come down in packets. So we don't know if the INMS packet will be the last one or a magnetometer packet or whatever, but they'll be coming back as quickly as we can send them back. So we'll find out with that final bit.
Well, actually, and we'll see the radio signal dissipate. So our very last bit of science data, if we don't get a complete packet, it could very well be the radio science.
All right, lots of folks are asking about what happens next. So Lisa here says, what happens to the team working with Cassini Saturn after the missions end? Are they just reassigned to new projects or missions at NASA, or are they off job hunting?
Well, most of the engineers, there is an active planetary program here at JPL, and a lot of our engineers have already kind of half semi-migrated over to these other opportunities. We're not having a big layoffs or anything like that. There's lots of work for everyone. Some of us have some paperwork to do, not just me. So there's a lot of documentation, and of course, the science data, to the extent that it can be funded by research grants, will continue for decades. So those opportunities for both our current and young scientists will be at least for another couple of decades. Got to be.
Right, and the Cassini scientists are funded for the next year, basically to make sure they carefully calibrate and understand all of this grand finale data to put it in the planetary data system. And from there, it will be accessible to future scientists. You know, who knows how many PhD theses will be written in the coming decades with Cassini data.
So indeed, Cassini's really given everyone on-the-job training on operating spacecraft and keeping our instruments healthy and analyzing the data. And so we have a cadre of highly capable scientists, engineers that will keep busy for many decades. You know, planetary program is doing well. We have tremendous support by the administration and Congress. We have missions that we're planning now, and we really have a very bright future.
All right, we've got time for another quick follow-up from Leo Enright from Irish Television. Leo?
I have a question for Earl and Linda about Enceladus, which is a tiny moon, not much bigger than Ireland, I have to point out. I mean, it's just astonishing that it's so active. Earl, do you have any idea of the chances that Cassini would have actually collided with this tiny moon? And for Linda, really, if you wouldn't mind just telling us, on the scale of things that you've seen in your extraordinary career, I mean, where does Enceladus fit in as the amazing surprise, as it were?
Well, we didn't do the math. Actually, I take that back. We did do the math several times for Enceladus, and as long as we could control the spacecraft, no problems. But we had a big challenge in an uncontrolled spacecraft, not hitting within a chance of 1 in a million Enceladus in the next 50 years. The issues are, of course, that once it's uncontrolled, you've got Titan out there pushing it around. It can push you just about, as you saw on those graphics, just about anywhere you wanted to go. And Enceladus was a good-sized target. So we didn't do the actual math for any of those other than to convince ourselves that an uncontrolled spacecraft either had to be well outside of Saturn, I mean way, way outside, or inside.
We have time for one last question.
Well, let me answer the second part.
Sorry,
For Enceladus, I would say Enceladus discoveries made by Cassini are certainly one of the most astonishing set of discoveries for planetary science. To find that there's an ocean world so tiny with the possibility of life so far from the sun, 10 times further from the sun than the Earth, has opened up our paradigm of where you might look for life, both within our own solar system and in the exoplanet systems beyond. So these ocean worlds, Enceladus, Titan also has a liquid ocean, has really changed our thinking about where to look for life.
Okay, well, I think that's about all the time we have for today for our briefing. Thanks again to our speakers and to all of you for your questions. Here's how you can watch Cassini coverage that NASA television has to offer over the next couple of days. Tomorrow, September 14th, we'll have a speaker program as part of our NASA social event on Cassini from 1 to 2 p.m. Pacific time. That's 4 to 5 p.m. Eastern. Then on Friday, we'll have live commentary from Mission Control from 4 to 5:30 a.m. Pacific. That's 7 to 8:30 Eastern. And following loss of signal, we'll have a post-mission briefing right here, starting at 6:30 a.m. Pacific. You can watch live at nasa.gov/live. More info about Cassini is available at nasa.gov, and you'll find a detailed online toolkit about Cassini's grand finale and end of mission on the mission website at saturn.jpl.nasa.gov/grand finale. And I think we've got a couple more minutes before the end of the hour. We'll end now with a replay of some of the images and video we've shared during our presentation today. Thank you so much for joining us.